All right, hello everyone. Welcome back. Hope you had a nice, restful, relaxing spring break. Hope you were able to get some break in during spring break. We do have some stuff going on in this class, of course, this week. Our second exam is coming up on Thursday, so I'm going to spend a few minutes up top just kind of going through the logistics, and then hopefully we can spend a lot of time going through some practice problems, writing some code, making sure people are ready for the upcoming exam. The good news is that the logistics really haven't changed much from the first exam. So just like last time, you are allowed to bring a sheet of paper with you, and you can put notes on it, whatever notes you want. Front and back, handwritten, typed. The same rules that applied for exam 1 apply for exam 2 as well. Also the location. So you should be going to the same room. I did not move any of these around, so the room assignments should be exactly the same as they were for the first exam. So please go to the same room that you took the first exam in for this exam as well. Really the only thing that's different, logistically wise about the exam is what's going to be on it. So last exam was over modules 1 through 3. This exam is going to be over modules 4, 5, and 6. So module 4, if you recall, was over APIs. This idea that if I tell you that a certain method exists and say this is how you can use it, that you should then be able to use it, even if you've never seen it before, even if you've never used it before, right? That's kind of one of the main things that we talked about in Module 4. And we use Standard Draw to help illustrate that concept, because Standard Draw can do a lot of drawing stuff for us, but we have to read about it first and understand how to use it properly before we can make that happen. Module 5 was about methods, so very, very important concepts. Methods really have a huge effect on the flow of our program and the order that things happen in, and that actually is probably one of the more complicated things about these few sections. And then Module 6 is really an extension of Module 5, in my opinion, because recursion relies on methods. Recursion really just another way of performing something that we already knew how to do using loops. We use loops to do repetition. We also use recursion to do repetition. So, yes, it does look a little bit different using method calls to perform repetition instead of using loops to do it. But they both have their uses. They're both good tools to have in your toolbox when it comes to writing code. The only other thing I wanted to talk to you about logistically wise is regarding the calendar that's coming up for this week. The other thing I want to make sure that you're aware of is the fact that there is no studio this week due to the exam, so we're not going to be taking attendance on Wednesday or anything like that. However, you do have an assignment due on Wednesday. Assignment 6 is due on Wednesday. The TAs will be in the labs on Wednesday to demo assignments and also to answer questions about the upcoming exam, but there's no studio. So, if you want to demo your assignment on Monday or Tuesday in TA office hours and then use that time on Wednesday to do something else, that is a choice that you can make. That is absolutely fine with me. I don't have a problem with that whatsoever. If you want to come on Wednesday and demo your assignment like you usually do, that's also totally fine. The TAs will be there. It's kind of your pick how to manage your time this week. Just want to make sure you're aware that there is no studio this week. We'll pick up with Studio 7 next week after this exam is over. Are there any questions about the logistics or what's happening with the schedule this week or anything like that I can address before we hop into doing some actual coding problems, practice review stuff? Do you have any questions about where they're going or what's happening? Everybody, all right, cool. Not seeing any hands, that's good. Then I also would like to just kind of remind you, hopefully you're already aware of this, but just want to make sure you're aware of the fact that just like on the previous exam, I did post some study materials for you. These past exam 2 questions are mostly going to be of the multiple choice fill in the blank style format. And then this is a repository that is filled with coding prep problems, both code reading and code writing problems. I want to also point out that there are lots of other coding problems in here as well that, while they weren't on the exam, right, they're all marked as non-exam, One of the questions I get asked most often is, where's more stuff I can do to practice? And the answer is right here, right? These are all, while these aren't past exam problems, they still cover the same topics that are going to be on the exam. If you're looking for more practice, this is where I'm going to point you to, and that is probably after you've done, a good chunk of these, right? Which is what most students prefer to use to study for the exam. But yeah, that's going to do it for my little speech. For the rest of the time that we have, I'm hoping to go through as many practice problems as possible, and I'm hoping that you will tell me which problems you would like to see me do. So I'm going to go ahead and take any suggestions, and if there aren't any, I'm happy to pick some, but I would much rather you all give me some direction. So does anybody have any problems they'd like to see me work through, or any questions they'd like to talk about? Yeah?
I would like to see the code writing question 1 being worked out.
Code writing question 1, yeah, let's do it. Great. Oh, we're jumping right into recursion. Okay, I guess I shouldn't be too surprised about that. That's probably a topic that's on a lot of people's minds heading into this exam. So this is actually also a drawing problem, so it kind of ties in some standard draw stuff as well, which is nice. You've been given this image 1 here. Can I zoom in a little bit just to see? And your task is to write code to recreate this image. Now, if I were going to give this to you on the exam, one of the questions that I get a lot about this exam is, how much of standard draw am I expected to know? And the answer is actually none of it, really. If you need to use standard draw on the exam to draw something, I will tell you what methods are. I will give you, I'm not going to give you all of the standard draw documentation. That would be a lot, right? And we don't need it all to do the exam. But I will give you snippets of the documentation about the stuff that you need. So for this problem, I would tell you that there's a method that's called, filled square. And that is the method that you should use to draw the squares. If I don't give you the documentation for it, then you don't need it. That's me telling you that I don't think you need it. I think you need the stuff that I'm telling you about, and that's all you should need to solve the problem. Don't feel like you have to memorize everything that standard draw can do. You don't. In fact, I would say that's actually not a good use of your time. Don't feel like you need to put, standard draw.filled circle on your cheat sheet. You don't. If you need standard draw.filled circle on the exam, then I will say there is a method called standard draw.filled circle that takes in these parameters and draws a circle on the screen. Use that method to do this. So use your cheat sheet real estate on more important things. Don't just copy standard draw documentation on there. But back to the task at hand. Now that that little speech is out of the way, we're using recursion here, and anytime we're tasked with recursive drawing problems, I don't want to say always, but a big chunk of these are within a certain category of recursive problems that we saw. This feels like the circles upon circles example from Studio, right? What kind of problem is that? We had a name for it. We had a category. It's usually hyphenated. Starts with the word divide. Divide and conquer. So these are divide and conquer problems most often. I can see that. I can tell it's a divide and conquer problem because I see that this basic shape in the middle is repeated 4 times, right? So this big shape in the middle is repeated in 4 different directions: up left, up right, down left, and down right. And so once I've identified that, that tells me that there's going to be 4 recursive calls. 1 to go up left, 1 to go up right, 1 to go down left, and 1 to go down right. So there will be 4 recursive calls that need to happen. That's maybe the hard part of these. The rest, I think, is usually pretty straightforward. The base case, since this is recursion, we need to talk about the base case. The base case is almost always going to be based on the size, which in this case is given to us as a half length. So the way I normally would say this, there's 2 ways you can think about this. If the half length is less than 0.001, if it's really, really small, if the size of the thing that I'm being asked to draw is really, really small, then why bother? I'm probably not going to be able to see it anyway. So, this would be do nothing, right? Or if you really wanted to, you could say return. What does the return statement do? It's a great exam question. If I type the word return here, what does that say? What is that telling me to do? Anybody remember? There's two things that return statements do for us. This is one of the two things. The thing that it's not doing is returning a value. So you can see that actually this says void. What's this called? This is called the return type, right? So the return type is void, which means I can't return 7, right? 7's not void. That's an int. I can't return, hello. That's a string, right? So it's saying there's no return value, but I can still do a return. It's the second thing that I care about here. I'm not trying to return a value. What else does return do for me? Anybody remember? Maybe this will help. What if I try and do something like this? Oh, now Eclipse is mad at me. Why? Why is this no good? Why can't I do this? Yeah.
Return ends the method.
It ends. When I say return, that means I'm done. Get out of this method. The method is over. There's no more work left to do here. So why is Eclipse mad at me? It's mad at me because this says I'm done, and now it's like, well, you told me you're done. Why are you trying to do more work? Or what it's really saying is that this is unreachable. I will never hit this line because you told me the line right before it that you're done. So I'm never going to get to that line. So return is one way. The two things that a return statement does, I can use it to return a value, designate what my answer is, or it can just simply mean stop. The method is over. I have no more work to do here. Get out. So that's one way to approach your base case. I think it's interesting to note that you could also say the opposite. I could say that while the half length is greater than some arbitrary value, then keep going, right? I can say the opposite as well. Both are valid. Doesn't really matter to me which one you use. I guess I'll stick with this one since that's kind of how I started. So this is our base case, and this is going to do our recursion. But remember, this is a divide and conquer problem, so I expect to see not just one call of recursion, but 4 of them, one for each of the divisions that we need to achieve. Let's start off by doing the not recursive part, which is just going to be drawing the square. I have to draw a square. So standard draw dot filled square. And we'll just use the given values, x center, y center, and half length. And now I need 4 calls. So I need to say recursive carpet. And I need to figure out how to go in all 4 directions. Up left. Let's just start with up left. Can I get the image back so I can refer to it? Here we go. So I am here. The next biggest square that I see in the up left direction is here. So if this is my center point, how do I get to this center point? It looks like I'm taking the half length, right? I'm moving up and to the left, so I'm going to be subtracting from the x direction, and I'm going to be adding to the y direction to move to the left and up. So the question is by how much? And it looks like it's going to be twice the half length, or twice the size, because this is 1 half length from the center to the edge, and then this is another half length from the edge out to the center of this part. So if I want to write that out in code, I would say that the x value is going to be shifted by 2 times the half length. And I'm subtracting because I'm moving to the left, I'm trying to go up and to the left. The y center value, since I'm moving up, is going to be added by 2 times the half length. And then the question is, okay, how does the size change? How big is this square compared to this square? So to get from this half length to this half length, right, it looks like it would be divided by 3. So here is where there's some wiggle room. I get asked this question a lot. Do I have to get it to look exactly like the picture? The answer is no. Actually, no. If you were doing this on the computer, you would be able to do some guess and check. But on the exam, obviously, you won't be able to do that. So is there a difference between doing, half length divided by 2 versus half length divided by 3? Yes. Do I care about that on the exam? No, I do not care about that on the exam. What do I care about on this problem on the exam? I care about that you've got the structure right. I care that you have a base case. I care that you're drawing the square correctly. I care that you have 4 recursive calls to represent the 4 different divisions that you are conquering, right? If you get these numbers a little off, not worried about that. Not going to take points off if the numbers are a little off. So don't spend a ton of time trying to get all of those measurements. You don't need a ruler, right? Don't worry about it. Eyeball it, do the best you can. If you're in the right ballpark, we're good to go. No need to worry about getting it super specific, super exactly right. Sometimes I even tell you exactly what those values should be just to remove any ambiguity. But let's try it out and see how far we are getting. Okay. Looks like maybe I made a mistake somewhere. Is it just 1 times that? Yeah. Something's not quite right. You can see that I'm off a little bit. This square is awfully big as well. Do you see that? But that's not necessarily the problem. I'm more concerned about the fact that it's gone off the screen. I'm a little bit confused about that. Is this length too big? I'm not sure. Let me try and think about this. I mean, I could divide it by a bigger number, which would shrink it all together, but... Oh, that seemed to make it... Did that make it worse? So... Part of this square is too big. But that's not my fault. That was given to us, right? So we could... What is the solution to this here? I actually think it kind of is working, to be honest with you. It's just the shapes are a little too big to fit on the screen properly. Actually, I'm pretty happy with the recursive call. I'm not seeing things in the other directions because I haven't written those recursive calls yet, right? So let me try and add on another recursive call and see if that moves us a step more in the right direction. If I want to move down left, right, then I'm going to keep the subtraction here, but then this needs to be subtraction on the y direction as well. So let's run that again and see if that moves us closer to our target. No? Now I feel like I'm doing something wrong, and I'm not quite sure. Oh, I know another thing that's probably going wrong. Now that I think about it. My base case, I think, is maybe arbitrarily too small. Let me tweak that a little bit. Okay. Whew. Now we're seeing things in that direction, things in this direction, and I'm actually going to tweak this to say to use a different size. I know this was given to you and you weren't expected to change this, so this is more of a my fault kind of a situation, but I do think it'll match the picture more closely if I... Yeah, okay, yeah. Matches the picture more closely if we start to shrink this a little bit. So that was my bad. Change your initial value to be smaller and you'll get better results back out. But let's finish up the last 2 recursive calls to get the full effect here. So I'm just going to copy this 2 more times. We did up left and down left. Now we have to do up left, or I'm sorry, up right and down right, which should just be shifting some of these signs, right? Since I'm moving right, that's going to go plus. Since I'm going up, all right, up, down, left, left, right, right. So that's all 4 directions, and yeah, I mean, it's not quite exact. My numbers are off, but again, I want to reiterate that it's drawing the proper pattern. I would actually say this is good. I would give this full credit. I think the issue is maybe this should be divided by 3 instead of divided by 2. But that's such a nitpicky thing that I would not take points off for. See, this looks a little bit closer to the image, right? This is looking closer to the image that you were given. Maybe we just need to go down another couple of layers. Oh, yeah. I mean, if that's not it, Well, okay. Super close. I actually went down an extra layer this time, it looks like. I went down one layer too deep. But we're definitely, in the right ballpark. Again, does not need to be exact. If you can get me here, that's great. That's full credit. All day. If you have this exact answer, but, you have a 4 here instead of a 3 or a 2 here instead of a 3, full credit. All day. Not worried about it. Not going to get nitpicky about what these exact numbers are. What I'm more interested in is, do you have the proper number of recursive calls? Are those recursive calls moving in the proper direction? Do you have a proper base case? That's what I'm looking for on these style of problems. Yes?
For the base case, are we just determining a number, an arbitrary number like that?
This is always going to be some arbitrarily small number. I think for some of these problems, I even tell you, stop when the shapes get to be smaller than this. I might explicitly say that on the exam. That's definitely possible. If I don't, then it's up to you, and I'm not going to complain about this number. Pick some arbitrarily small value and call it a day. Don't worry about it too much. Yep. Any other questions I can address on this problem? Any questions? There's a few other ones. You can see there's a few other images here too. So if you want more practice on this style of problem, there are a couple other ones available. Does anybody have another problem they would like to talk about or see me work through? I have a couple ideas, but I'd rather take some from you first. Not seeing any takers. Let me do another recursion related one with you. But I actually want to do a code reading problem that's recursion related. Let me see if I can find the one that I want though. That's not the one I want. Here we go. This is a good one. So it says, use the substitution method to show the computation of this. The substitution method quite literally is asking you to pretend you're the debugger and walk through the code step by step. So there isn't necessarily a specific format that I'm looking for the substitution method, but there is a certain amount of information that I'm looking for when you write out the substitution method. So I'm going to walk through this problem, the way that I would solve it, and then yeah, we can chat about that. So if you're being asked to do the substitution method, which you probably will be, spoiler alert, right? Like that's probably going to be on the exam. The first thing I'm going to do is say, all right, I'm starting at foo of 4. And then let's walk through the code. 4 is not less than 0. 4 is not equal to 1. So I'm going to be doing this else statement. Okay. So then that says I'm going to do foo of, well, this will be 2. Oops. Plus the letter C plus the foo of 3. And we actually kind of have two places that we're going next, right? Foo of 2 and the foo of 3. So it doesn't really matter which one you pick, I suppose, right? But I have to figure out what these two things are. What are these two things? What are they? Okay. This is going to be equal to, all right, so 3. If I plug 3 in, is 3 less than 0? It's not. Is 3 equal to 1? It's not. So, oh, surprise, surprise, I'm back here again, right? Foo of 3, I'm sorry, this will be foo of 1 plus C plus foo of 2. So I figured out what this one is, but I still need to figure out, what this is and what this is. Let's do foo of 2 next. Foo of 2, still not 0, still not 1, or still not less than 0, still not 1. So this is going to be equal to foo of 0 plus the letter C plus foo of 1. All right, what is the foo of 1? Ah, this is a good one because we've now hit our base case. This is equal to B. But actually, we also need the foo of 0. So So this is equal. This is actually a second base case. We can have more than one base case. There's no reason saying that. There's nothing saying that we only need to have one base case. Consider we're using recursion to do repetition. I can have a while loop that says, while this, and that's the same thing as having two recursive base cases, right? So this is similar to having a while loop with an and statement, just doing it the recursive way, having two base cases instead. So for foo of 0, we're going to hit the letter A as our base case. We've actually hit the bottom. Notice that there's nothing over here. There's nothing, I haven't missed any, right? There's no method calls over here that I haven't figured out over here. And so now we need to work our way back up. Once I've hit the base case, I'm not done yet. I actually need to work my way back up to the original method call. And this is where the substitution method gets its name. I'm going to substitute in the values. So if I look at this one, you can see that it relies on this value and this value. I know what those are now. So I'm going to substitute them in. So the way that would look would be to say foo of 2 is equal to A, because that's what this is, right? Plus C plus B, because that's what this is. And so if you put that all together, you end up with ACB, all as one string. Everybody with me so far? So now that I know what this is, I can substitute it in anytime I see this. So, okay, now if I want to revisit foo of 3, this is still B, just like it was before. So, okay, that's B, plus C, that's from this part here, plus the result that I have for this statement, which is going to be this stuff. And if I put that all together, I get B, C, A, C, B. All right, almost done. The foo of 4 is going to be whatever this needs to be substituted in for. So that's going to be ACB plus the C that's in the middle plus whatever this value has been computed to be, which is this guy right here, BCACB. If I put that all together, I get ACB, CB, CA, CB. Which I know seems complicated, right? This answer looks a little complicated, but hopefully stepping through this, one call at a time, right, shows you how you can actually piece this together from all of its component parts. I also want to reiterate that this is how the computer executes this code to some degree as well, right? Drill down to the base case. Once you've hit the base case, then we have to go all the way back up to where we started and fill in any of the gaps along the way. That's exactly what we did with the substitution method. And again, just to kind of show that hopefully this does in fact work, let's run it and get the answer back out. Check my work, see if I made a mistake. Boop. Oh, I need to print it. There's no print statement. There we go. Now it should hopefully show me the answer. ACB, CB, CA, CB. Does it match? Yeah. Beautiful. As far as the substitution method goes, there are some other ones in here. So here's another substitution method, and there's another one. But I picked one that is probably, this is probably the trickiest one of the bunch. So if you understand how this one works, then you understand the substitution method pretty well. Question?
How does, once you hit the first base case of x equals 1, how do you get to the x equals 0 base case?
I see that I need it here, right?
Yeah.
So I can't compute this. I can't compute what this is until I have this. And that tells me that I need to add another line. So maybe I wasn't actually explicitly clear on that. when I first write this out, I see this statement, and that tells me that I have to write down those over here and figure out what they are on the left.
Okay.
And then anytime I see a method call that I haven't already, added to my list, then I'm going to add it to my list and have it be one that I figure out. A lot of times it won't be as difficult because, the reason I think why this one is more difficult, there's two recursive calls, right? There's one here and there's one here. I think most of the substitution method examples that I've shown in class don't do that. They just have one recursive call here instead of two. So that does make this one a little bit more complicated. But if you go back and take a look at like question 12 maybe, yeah, question 12 for example, is a little bit more straightforward perhaps of a substitution method problem to work on. I did pick a harder one for sure. Any other questions I can address about this problem? Or if you want to see me do another substitution method problem, be happy to do so. Any other places you'd like to go? Any other problems you'd like to see? I suppose I've already asked you this a few times. Did you have one?
Yeah, well, I just had a quick question.
Yeah.
It's like for the exam, we don't have to write it in that particular way, right? That's what you said.
You don't, but I am going to look for certain things, such as do you have all of the proper method calls here, right? Do you have all, because that's an important part of it. I think it's also important to understand that if I set a breakpoint here, right, and I start working my way through this problem, what am I going to see? I'm going to see exactly these method calls that I've written down here. They're going to match. So here, I think that's a good thing to be able to do as well, is use the debugger and start stepping through this code one line at a time. So here I am for x is equal to 4. That's going to take me down, and it's going to say, oh, go do x is equal to 2. Okay, so here I am now doing x is equal to 2, and then it'll say, all right, now you have to go do x is equal to 0. So we actually hit that. It actually did things a little bit different than me. It went right to the base case and got this first, and then it's going to go back and figure that one out next. But the end result will be the same. So yeah, any other questions on this problem? Might do another substitution method one later if we have time. But let's do some more code writing problems, because I think those are definitely the kinds of questions that I get asked about the most. I'm going to do a not recursive one because, and actually I think that's something that's important to keep in mind as well. Students get hung up a lot because we cover recursion, and I know recursion is hard, right? Recursion is definitely one of the more difficult concepts we cover in this class. Not going to deny that that is a fact. But remember, there's 3 modules on this exam. Recursion is 1/3 of what we have covered. So I think what happens is sometimes students spend so much time trying to study recursion and get used to recursion that when the exam comes, they're trying to cram recursion into everything. And that is not needed. In fact, the opposite, I'd say, is going to be true. On the exam, if you need to use recursion on a problem, I will usually tell you. I will usually say, in bold letters, you have to use recursion on this problem. If you use a loop on this problem, you won't get any credit. Sometimes I might also say the opposite. Sometimes I might say, you have to use a loop on this problem. If you use recursion on this problem, you won't get any credit, right? That's also possible. If I don't say either of those two things, then it's up to you to decide whether to use a loop or whether to use recursion. And I mean, I would almost always choose a loop in that case. So what I see sometimes is students trying to use recursion for everything, even though I didn't explicitly ask for it. A lot of times that might overcomplicate the problems where you don't actually need to use recursion. So read the problem. Make sure you understand what I'm asking for. If I don't say you have to use recursion and you want to use a loop, then please use a loop, right? Like don't feel like you have to use recursion. This is kind of a good example of a problem, right? Here it says it is not necessary to use recursion. So that means, you can use recursion if you want to, and I think some students even did try to use recursion to solve this particular problem. But you don't have to, right? You don't have to use recursion. If you want to use a loop to do it instead, then please use a loop to do it instead. So let's run through this problem. I actually think that this is an interesting problem to do both ways, both with a loop and with recursion. So we might solve this one twice. But let's do it the loop way first, because I think that is the more straightforward way. And again, if it's up to me, I like recursion, right? Like, I can talk about recursion all day. But if you give me the choice, do you want to solve this problem using recursion? Do you want to solve this problem using a loop? I'm going to choose a loop 99 times out of 100. So don't feel bad for doing that as well on the exam. Let's return to this problem at hand. You're given a one-dimensional array, and you're asked to sum all of the values that are even. So I'm not going to add up to 3, but I'll add up the 4, the 6, and the 2, and this 4 to get 16, right? So 4 plus 6 is 10, plus 2 is 12, plus that 4 gets me 16. I add up all of the even numbers. I ignore all of the odd numbers to generate this sum, right? So here, what I'll do for a lot of these is I will oftentimes give you the method declaration. What I might do, I didn't do it on this problem, but I do want to give you a heads up. Sometimes this might be blank. And so you might have to read the problem and be like, oh, okay, this is clearly going to have int as a return type, right? And fill in that blank. Sometimes I might also do that here. Sometimes I might have this be a blank. And you would have to look at the example and say, okay, this says sum evens of A. That means that there is one parameter, and the type of that parameter is an integer array. And you would have to fill in that blank, right? Sometimes I might just give it to you. So for this problem, you can see I did just tell you what the return type and the parameter should be. But I do think it's fair game to have those be blank and make you fill those in based on the story that you're being told. I think that's a reasonable thing to request. Back to this task at hand. I just need to go through this array and find all the even values, right? So, okay. This is actually kind of review from last section, if you ask me. You could even do a, I think this is a great example of using a for each loop, honestly. If you wanted to, you could say, int value in A, and then if the value is even, if the value mod 2 is equal to 0, that's how we know it's even, then we wish to sum it up. But we need a variable to store our sum, right? So I'll say int sum is equal to 0, and then once I have found an even value, then I can just say sum is plus equal to that value. I'm almost done. It's one very important thing that I forgot. Anybody see what it is? I need a return statement. If this is anything but void, I have to have a return statement in my method. Have to. If it is void, I can use return statements if I want to, but I don't have to. But if this is anything other than void, there has to be at least one return statement in here to specify what this integer is, right? I have to give you an integer back. In this case, it's just going to be the sum that I've computed. So once the loop is over, I can just return sum. So let's try it out. It clearly says here this should be 16. If I run this code, hopefully it'll give me the 16 back out. There it is. Great. But I want to do this recursively too, because I think that'll actually be kind of a good little exercise. Before I do that though, did you have a question?
I had a question about if you do use this recursively.
Okay.
So you do that first and then ask me.
Okay, sure. Any other questions about the loop version before I switch over to the recursive version? I want to be absolutely clear. You didn't have to use recursion for this. So if I ask you this problem on the exam, this is the answer. Don't overcomplicate it by adding recursion in there if you don't have to. If this seems like it's simple and straightforward, good. Good. I'm glad. Right? That's good news to me. It should be simple and straightforward, I hope. But let's talk about recursion. When doing recursion, right, the recursion is doing repetition. Recursion is used to perform repetition. So that means that one trip through this loop should be roughly equivalent to one trip through my recursive method. Sorry, my brain went blank there for a second. One trip through this loop should be equivalent to one trip through my recursive method. So every trip through my recursive method, I'm going to look at one value from the array, ask if it's even or not, and add it if I need to. And then the next time I do recursion, I'll look at the next value in the array. Now there are some issues with this, right? And hopefully you've already maybe got some alarm bells going off, like, oh, you want to use an array with recursion, huh? Like that might be an indication that you need a little bit of extra help to pull that off. There's something called a helper method that I think we're going to need here. So anytime you're doing recursion with, I don't want to say anytime, there are always going to be exceptions, but a lot of the times if I'm doing recursion with arrays, a helper method is a useful tool. There are two reasons why I might want to use a helper method. Can somebody give me one of those two reasons why I might choose to use a helper method when I'm doing recursion? Two primary reasons. So one reason, which I think matters to us here, is the idea that inside of this loop, right, I need to access this sum variable, but that sum variable is created outside of the loop. So in other words, I'm creating a running sum, but I need to somehow track that value. And in order to do that with a recursive method, I'm going to need probably an extra parameter. And actually, I think the array is another indication of why I might need a helper method. A lot of times I have what's called a loop variable, right? For int, I know I did this a little differently. I did this using a for each loop instead of a for int I equals 0 loop. But, a lot of times I have a loop variable for int I equals 0, I less than a dot length, etc., etc. If I want to use that loop variable while I'm doing recursion, I need an extra parameter to tack that loop variable on and have it travel with each recursive step. So that's one of the two reasons why helper methods are often used. The other reason why helper methods are used is because sometimes there'll be stuff that is repeated, and sometimes there'll be stuff that is not repeated. So the helper method is used to isolate the repetitive stuff from the non-repetitive stuff. The helper method is going to contain the repetitive stuff, so this is going to go, this code, well, not this exact code, but this functionality is going to go in the recursive helper method. And anything that is not repetitive, anything that's outside of the loop, like this guy right here, is going to be outside of the helper method. This only needs to happen once. I don't want to put this inside of a recursive method because I don't want to repeat this line. I only want to do it once. Yes?
Like, if you didn't use a helper method, then it would just keep having the sum equals 0 every time you recurse.
Correct. Yeah, the sum would get reset to 0 because the recursive method gets repeated, so this would get repeated every time I called the method and just reset it back to 0. Exactly right. So let's go ahead and start to construct this. I'm going to need two methods. One of them is going to do the non-repetitive stuff, and one of them is going to do the repetitive stuff, and that one is going to be my recursive method, the repetitive one, because that's what recursion is used for, right? It's to do repetition. So, okay, I'm going to make this first method sum evens. I usually tack a capital R on the end just to remind myself that this is the recursive version, right? Not the version that uses loops. And I take in this a parameter. But before I put any code in here, I also want to kind of set up my helper method. So public static int sum evens helper. So what are the parameters that I need? What does the repetition need to do its job? It needs the array. I don't really see how it can do it without the array. It needs access to this sum variable. So I think that needs to be a parameter as well. And then it also needs some way of determining where it's at, right? Where it's at within the array. So I actually think we need three parameters here. I think we need some int call it I, right? That's our loop variable. And then we also need some int to keep track of our sum. Oops, I put those in the wrong method. I'm so sorry. Those should go down here. A, int I, and int sum. My bad. The extra parameters are always going to go on your helper method. Remember, that's one of the two reasons why we use helper methods. So that we have additional parameters and also to isolate the repetitive stuff from the non-repetitive stuff. So if we go back up here, I want to do the non-repetitive stuff first. So I want to say, you know, int I is equal to 0. Int sum is equal to 0. Right? These are things that only need to happen once. And once I've created these variables, then I can kick off my helper. Plug in the array, plug in the initial value for I, plug in the initial value for the sum. No repetition here, right? No loops, no recursion. That's not what this method is for. This method just sets up some variables and then kicks off the repetition, kicks off the recursion. So now we're going to come down here and we're going to do the recursion. You know, I want to stop the same way I do here when I hit the end of the array. So if I've gone off the end of the array, then I'm done. I know I'm done. So I is what I'm using to keep track of where I am in the array. So if I say, you know, something like if I is greater than or equal to, it has to be greater than or equal to the length, right? Because we start from 0. That's kind of a review question from last time. Then I'm done. If I goes off the edge of the array, what's my answer? What's my sum?
0.
I would argue it's 0, right? There's nothing out there for me to add up. It's 0. Actually, let me think about this for a second. Do I even need this parameter? I'm not sure I even need this parameter, do I? Let me keep going, and I might actually be able to simplify this a little bit now that I think about it. Otherwise, I'm going to return, well, I'm going to do my recursive stuff, right? Sum evens helper. I have to pass in the array. I have to pass in a value for I, but I want to make sure I keep moving, right? So I don't want to pass in I by itself. That will not get me any closer to the base case. I have to make sure that I is going to keep progressing, keep moving. So I want to do I plus 1. And I actually think I might have made a slight mistake. There's more than one way you could do this. I think that you could use this third parameter, but now that I've done this, I'm not so sure that it's actually necessary because I can say a at I plus this, although I first need to do the check to see if it's even or odd first. So if this mod 2 is equal to 0, then I'm going to return this. Still not quite done though. Otherwise, you can see that, I don't know, I keep changing my mind on whether I like this solution or not. If it's not even, then I don't want to add this term, right? But I still need to keep the recursion going. Still have to keep this recursion going. So if it's not even, then I'm just going to do the recursion and I'm going to leave this term out. Does that make sense? So if this term is even, I'm going to add it in and use the recursion to keep moving. If this term is not even, I'm not going to add it in. I'm going to ignore it, but I still need to use the recursion to keep moving until I check all the values. So yeah, I think I actually convinced myself that I only need 2 parameters here, not 3. And then the one final thing that's missing, because this says it needs an int. Students forget this a lot, right? This needs to return a value as well. A lot of times I'm going to be returning this value here and then just returning that value right away as well. This ended up being perhaps a little more complicated than I was hoping it would be, but it's not too bad. I think this is actually very similar to a lot of the helper method problems you were asked to do on the studio and the assignment as well. Let's make sure it works though. I want to actually verify that this works. I'm going to change this to use the sum evens R, because that's my recursive version. Without the R is my loop version. So I'm going to switch that to use the recursive version and run it, and hopefully I get my 16 back out like I did for the other one. It worked. It worked. But I think it's worth either running this through the debugger or working it through the substitution method, or maybe even both, just to really solidify, right, how this is working from a recursive perspective. I'm going to use the debugger. I feel like I haven't used the debugger enough in this review session. I was using it a ton last session. This session I haven't used it that much yet at all. So let's run this one through the debugger and make sure we understand exactly how this recursive method is working. All right, here I am at the very beginning of the program. Here's my array with all my values in it. We're about to step into the non-helper method. Oh, I've got an extra line of code here. I'm not actually using this anymore, but it's not hurting anything, I suppose. I start I out at 0, and then I kick things over to my helper method. That's going to be my recursion, right? Okay. Here I am. I'm now going to see, have I gone off the edge of the array? Well, no, I just started. I is equal to 0, so I'm not off the edge of the array yet. Okay, since I am doing the first value, is the value at position 0 even or odd? So I look at it and I say, oh, that's 3. So that's odd. That means that I am not going to add that term in, and I'm going to skip down here, which just says use recursion to move to the next value. Okay. So I step into that. Notice, though, that this method didn't disappear, right? It's sitting there waiting for me to continue working on. I is now 1, and I'm going to do the same thing. Have I hit my base case? I haven't. 1 is still not past the edge. If the value at position 1 is even, which it's a 4, this time it is, in fact, even, then, okay, notice I ended up here. Now I'm going to have 4 plus whatever this recursive stuff is. But we're still not done yet. We have to keep going until we hit the base case. So I is now 2. That is another even value, apparently. I is now 3, which is another even value. I is now 4. That's an odd value because I jumped down to the bottom. I is now 5. There's another even. 6. Still haven't hit the base case. Am I there yet? Okay, yeah, finally hit the base case. Notice how many recursive calls I have over here. 1 for each element in my array, right? Plus 1 extra for going beyond, for the base case, for going beyond the end of the array. I also have to work my way back up. I haven't actually added anything yet. I haven't actually done any addition yet whatsoever. None. That's all going to happen on the way back up. So here I say return 0. I return back here, and there's nothing for me to add. This was an odd number. The value of position 6 was odd, so there's nothing else for me to add to 0. So my answer is still 0. But if I keep working my way back through these methods, okay, the value at position 5 was even. So I'm going to take that 4 and add it to my 0 to get 4. And there it is. You can see that I've computed that 4. This is another odd value, so nothing to change here. But now I've hit another even value at position I is equal to 3. So 4 plus 2, it's going to get me 6. Another even value at position 2 is going to get me another 6 onto that, which will get me 12. And yet another even value, position 1 is this 4. That gets me 16. I look at the last odd value, nothing to do there, so I just say, here's your 16. And that's going to be what gets printed out. So a little trickier than perhaps I originally envisioned, but a good example of how to use a helper method. I actually think you could have also done it using the third parameter like I originally started out. I think there's another way to do it that uses that. If you came across that solution, that's great. I think that's totally good. Both are fine, right? The important concepts when it comes to helper methods are understanding that they're used to isolate the repetition from the non-repetitive stuff and are used to give us additional parameters so that we can have access to the same values as we would if we were using a loop. What other questions do you have about this problem before we move on to another one? Any questions? Yeah.
And so odds are, if there is a question like this, you will say like it's not necessary to use recursion, or like it's whatever you decide.
On this one, I said it is not necessary to use recursion. So I think that's a good thing to keep in mind. Is the official answer to this problem is probably more like this. Would I accept this recursive implementation for this? Yes, but I would imagine it's going to take you longer to figure out and write out. So if you have the option, right, I would much prefer to do it this way. And if I don't tell you, then do it that way. Also, I think a lot of times, in fact, you'll see this in some of these other problems too. If I ask you to use recursion, sometimes I'll even take an additional step and say you have to use the helper function. So, I think it's definitely possible that I am. Yeah, let's see. Yeah, you should use the helper method. Yeah. So sometimes I'm going to tell you that directly. Other times I'll say you have to use recursion and a helper method is not necessary. So, I will try and give you a push in that direction. Yeah. Good question. Any other questions I can address about code writing question 11 before we take a look at some other stuff? Should have time to do at least a couple more, I hope. Trying to think what other problems we should do that would be good for you all to see. Here's another recursive problem. This one, see, here's another example. It says you do not need a helper method to do this, but you can if you want to, right? You can use the helper method if you want to. This one I think surprises students sometimes because the answer is pretty darn straightforward, actually. I don't know if any of you have had a chance to figure it out, but let's talk about it real quick. I want to write a method that counts how many digits there are. So there are clearly 7 digits in this number. There are 4 digits in this number, right? But I want to do it recursively. So I think this is a good example of how do I identify the recursive substructure of a problem. So if I say, whoops, there's an error down here. This should say num digits. That's my bad. But, so I think this is a great example of figuring out how to identify the recursive substructure. Right? If I say this is, I want to figure out the number of digits of this, I would say that it's going to be, well, I have at least one digit plus however many number of digits there are for 100. And how did I get from 1,000 to 100? I got there just like you think I probably did. I divided by 10. And I would argue that would work for anything. If we take a look at the first, pick a different number. If it's 1, 2, 3, 4, right? That's going to be equal to 1 digit plus however many digits there are at 1, 2, 3. There is a little trick. There is a little wrinkle. Yes, I'm dividing by 10, but there's a specific version of division I'm using. What kind of division am I doing here? To get from here, I'm saying to get from here to here, I'm dividing by 10. Is that true? It is if, what type of, yeah, I heard somebody whisper integer division. Yes, this is an integer. This is also an integer. This integer divided by 10 will give me this, right? Because integer division ignores decimal places, right? So I think that's kind of the little wrinkle here. I can get there by dividing by 10. As long as I do integer division and I don't mix any doubles in, this should actually work. So, the number of digits for 1, 2, 3 is always going to be 1 plus the number of digits for 1, 2. So what I'm really looking for is the recursive substructure. And the recursive substructure is the general form of this. The number of digits of n, right, is equal to 1 plus the number of digits of n divided by 10. Does everybody see how I got, from working out a concrete example to working out a more general example? The reason why it's good to keep it general is because this I can turn into code. This I can't really turn into code, right? It's close, but I need the general form. I need the general version of this, so I need to figure that out. And this I can turn into code. If we return to our base case now, right? Actually, that's the one thing we haven't talked about. What's our base case? What's our base case? I think that this is a clue, right? If the value is less than 10, then the number of digits is 1, 0 through 9, right? Does it say positive? I think it says, does it say, oh, it actually doesn't say what you should do with negative values. I'm trying to think if that would actually, I think the only thing that would change is you would have to ask if it's less than negative 10 and greater than, less than positive 10 and greater than negative 10. I think otherwise it all still works. But yeah, if it's less than 10, return 1. Maybe we can experiment with that in just a second. Otherwise, return 1 plus num digits x divided by 10. I think this is the answer. I spent a lot more time, working through how I got the answer. Conceptually, right, this looks like a simple amount of code, but conceptually, figuring out how to get there, I think, is kind of the tricky part. Identifying this recursive substructure. Once you have this, very easy to turn this into code. I see this line of code right here, right? So very easy to turn that into code. Let's make sure it actually works, though, too, huh? Always good to make sure things are working properly. So 7 digits in the first value, 4 digits in the second value. Appears to be working. What I'm a little unsure of is what would happen if I made one of these negative. Actually, I think I could figure it out pretty quickly. What's going to happen if I make one of these negative? Is a negative value less than 10? Sure is. So any negative value is going to tell me 1 every time. Can we fix that? We sure could. Actually, I think that the way to fix that is to note that this is still the same number of digits as the positive version of it, right? So why don't we just check for that first? If the value is negative, flip the sign and count the digits, right? That's kind of what I would maybe try to do. This isn't part of the problem, by the way. This is maybe a little bit extra above and beyond. But if x is less than 0, then, okay, we're going to return num digits of negative x, right? Flip the sign and then ship it back through. I think that would work, but let's try it out. Yeah, cool. Now we can handle negatives as well as positives. I think the way this question was written was a little bit ambiguous. I don't think I was expecting people to handle negatives on this one. But it's actually not that much extra work to handle the negative case as well as the positive case. A lot of the recursive methods that I ask you to write are going to be short and simple. If you find yourself writing long recursive methods, that's kind of a red flag that maybe you've gone off the beaten path a little bit. Does that mean these are going to be conceptually easy? No, not necessarily, but usually the amount of code you have to write is not a ton. So, and the same was true on the last exam, I hope, right? If you find yourself writing 20, 30 lines of code to answer a question, you're going the wrong way. You're taking a much longer path than you need to get there. I'm not going to ask you any questions on this exam that take more than a handful of lines of code in the typical case. Not on purpose. I do make mistakes, but usually I'm trying to keep the answers pretty short and sweet. Cool. What do we got? We got 15 minutes left. I think I can probably do at least one more coding problem, maybe even a couple. I know I've already asked you a few times. I'm gonna ask one more time if anybody has any that they would like to see me do before I randomly pick out another one for us to wrap up for today. I'm not seeing any hands. Let's find a fun one to work on. Do we want to do recursion or no recursion? Does anybody have any opinions about that at least? Yeah. Question 3 of the code writing? Yeah, be happy to. Thank you. Another recursion one. Awesome. Let's do it. I haven't actually done this one yet today, I don't think. Which is great. Another thing to kind of remind you of, since we're getting sort of close to the end of class today, I had another review session right before this, and I recorded that review session just like I'm recording this one, and I think I did entirely different problems. Like, I don't think I duplicated one problem today. So if you want to get some more review, go watch the video from the first review session. It's a whole different set of problems than what I did in this session. So, but yeah, let's go ahead and tackle this one. Let's take a look at the image. Okay, here's the image we got. It's a drawing problem. It's a divide and conquer problem. We already kind of talked about this a little bit. Hopefully it's easy to see what the directions are, right? This time I'm going down and to the left and down and to the right. There's only 2 directions. I only see 2 directions here. Start from the big square, work your way to the smaller square. So if I start from the big square, then I go down to the left and then I go down to the right. So, and then as I've already mentioned, if you need to draw anything, I will give you information about that. So I will say, hey, here's a method called square that you can use to draw squares, and here's the information you need. So that will all be provided to you on the exam. Let's run back here now and see if we can't figure out how to code this up. Just like before, the base case is going to be some, arbitrarily small value. So there's going to be something, here we go, half length. If the half length, I might do this a little opposite than I did last time. If the half length is greater than 0.001, then keep going, right? If the half length is less than this, then what's going to happen? It'll just skip the whole thing and leave, right? It's a little bit different than how I did the first problem, but gets me the same place. Potato, potato. So okay, now we can draw our square. And we'll just use the given values for that. X center, Y center, and the half length. But now we have to figure out where to go next. And that's always the tricky part with these divide and conquer problems. I need to have 2 recursive calls. One that moves me farther down and to the left, and one that moves me farther down and to the right. So if this is my center point, and I want the next center point to be here, how do I get there? Down is negative y direction, left is negative x direction, and it looks like I'm subtracting the half length from both. So my recursive call would be something like boxy x coordinate minus the half length, y coordinate minus the half length. And then how does the size change? So from here to here, it looks like I'm dividing the half length by 2. You can see that this half length, right, is about a quarter of this. So here's the original half length, and then here's the new half length, and this one looks to be about half the size, right? From here to here is about half the distances from here to here. So if we divide that half length over 2, I think that's going to give us the down left. But let's try it. I know you can't try it on the exam, but I can try it now, so let's try it. See if it, okay, yeah. Looks like my base case might be a little bit too fine-grained perhaps, but it's still going down and to the left appropriately. So then the other thing we need to do is go down and to the right, which is going to be a copy of this recursive call, just moving the signs. So rightward would be positive x direction, but still negative in the y direction because I'm still going downwards, right? The half length is also going to still be divided by 2, and now if I run this guy, hopefully I get something that looks... I think my base case is perhaps a bit too small, right? Too far down. But if you compare the images. This one stopped sooner. You can see the boxes don't get as small as the ones that I've drawn. I don't care about that. If that's the only difference between the answer you give me and the picture, 100 point, well, not 100, full credit. That's what I need to say. Full credit on the problem. But yeah, this is, you know, the actual value seems like maybe there's another 0 taken off here or something like that. Just to see how close I can get it. Oh, I mean, that's almost exact, isn't it? Come on. Or am I, now I'm one level too short. Same story though, like not gonna be that nitpicky about it. If you can give me this drawing, that's great. Full credit, not gonna complain about that. Question?
Could you tell me why, like, you could use the base case like greater than or less than, and like it would perform the same task? Like, why can you use like the greater than instead of like the less?
Well, let me show you. Let me show you actually. I can redo this. I can rewrite this a little bit. So here I'm saying if the size of the square you want to draw is big enough, then draw it and keep going. But I could say the opposite. I could say if the size of the square that you want to draw is small, then stop. Return in this case means stop. We're done. There's nothing left to do. Otherwise, keep going. So I would argue that what I have up here now and what I had up here just a moment ago, exactly the same in terms of what's going to get executed and what's going to get drawn, written slightly differently. The biggest difference is honestly just the sign, just flipping the sign. But if I run the code, I expect to get yeah, the exact same picture back out. So potato, potato. Yep. The way I did it before, I mean, the nice thing about this, it's a little shorter, saves a little bit of writing. A few more minutes to work on another problem. Hopefully time's not an issue on the, that's never my goal. Is I definitely hope people have enough time to finish the exams, but I know that time does matter, so every minute counts. Any other questions about this problem or anything else that I can address for you all at all? So we have less than 8 minutes left. I don't think that's going to give me quite enough time to walk through another problem, but I'm going to stick around. So if you have lingering questions and you want to come chat to me after class, please come on up and talk to me. I'd be happy to answer some more questions for you. Go back and watch that other review video. Like I said, I did a whole different set of review problems last time, so be sure to check that out. And that's going to do it for today. I will see you either in the labs on Wednesday or at the exam on Thursday. Have a great week, everyone.